Alright, welcome back. Thank you very much for watching. Today we have what I think is a Wells Gardner K7400, and this was sent in by somebody who powered it up after 5 minutes. It had vertical collapse. Full cap kit, installed a vertical IC, tested, still collapsed, removed the LA7850, replaced it, it's no change, tested, can't figure it out, broke a capacitor, replaced it, did all the test point checks and everything seemed okay. So they're stuck at vertical collapse. So let's go ahead and see if we can figure out what's going on here. Neck board seems okay, but got a very low usage hour. The board's not burned up like most of them are around the heat damaged area on the heat sinks. So visually it appears to be a very low hour chassis, so that's good. Kind of unorthodox packaging here, but I guess it gets the job done. And yeah, this is a K7400. You can tell because of the way that it is. I'm just kidding, I'll show you how you can tell here in a minute. Alright, so if you look here, on all these series of chassis, there's a little identification tag here. And you can see here 7401, so this is a K7400. So, yep, alright. Let's go through here and take a look visually. Yeah, I mean, this is very clean. This looks like it might be right out of a brand new monitor. However, it does have some hours on it because there's a lot of heat, visual evidence of heat coming off of this resistor here. This resistor and this resistor generate a lot of heat coming off this horizontal transformer here. So yeah, there's evidence of that. So what we'll do here is we'll push down on the board at the same time we lift up on the plastic, and you can just slide this right off like so, because there's a little clip in there that holds it in. So we'll get rid of that. And just visually looking at it, let's go ahead and, I don't want to really remove anything yet because I want to test it and verify. Step number one is always to verify the issue. You don't want to spend hours and hours troubleshooting something where there's we got a linearity coil that's lost its way, but we'll try and remember to glue that back in place. But what I was saying was you don't want to spend hours and hours troubleshooting something that doesn't exist, because let's say the person has an open, let's say the winding on their vertical yoke, or the vertical winding on the yoke, there we go. Let's say that's open, or there's something wrong with their monitor or their yoke, and you spend hours trying to figure out what's wrong with the chassis, only to find out that there's nothing wrong with the chassis. So step number one is always verification of the discrepancy. The B+ pot looks like it's adjusted improperly, so we'll verify that just visually from looking at it. It doesn't appear to be in the correct spot, but I could be wrong. Visually speaking, it looks pretty good. Yeah, nice and clean. Don't see much wrong with it. And U701 is in fact in the socket. So, looking at the back side, very nice job. If they replaced they replaced U601, and it did a very nice job. Looks like a very nice job overall on all of the work here. I must say, yes, the cap kit work and the reflow and the replacement of the chips, very nice job indeed. So kudos to that person. All right, so I don't think we're going to have any symptoms of bad rework. And I mean, if this was originally, as this was from the factory, they turned it on their monitor and it worked and then collapsed, and now it's completely collapsed permanently. I have to say that I don't think it's going to be anything that the person did, because they're no worse off after they did the work than they were before. So, all right. Well, let's just turn it on and verify the discrepancy first before we really do anything, and see where we're at with that, and kind of go from there. And after saying that, I realized that I don't know why I took this off. I'll put it right back on here. There we go. We're going to have to remember to fix this linearity coil. The magnet is still attached to the bottom of the coil here, but we need to just glue it back in place onto the cardboard support there. So, yeah. All right, so if you're not aware, there's a wrapping of wire around this ferrite core thing, and then there's a magnet on the top and a magnet on the bottom, and you can change out the magnets or move the magnets around, and it affects the inductance of the coil, and it'll affect your linearity. Your horizontal, this is horizontal linearity here. So, yeah, that's why it's important to have the right magnets in there, have them in place properly, and have it be sitting properly on there. So we'll mess with that later. So anyway, let's get a tube, get this on the tube and fire it up and see. We'll measure the B+, make sure it's set properly, and see where we're at that point. Well, I've got the camera on the overhead still. I haven't taken it off yet. And I'm hooking up the chassis here to the tube, and as I go to hook up the anode onto the tube, I noticed that I don't know if this was damaged previously or by the owner or before the owner got it, but one of the clips is broken off for the cap here, and then also the other one's kind of bent way over. So I think maybe somebody bent that way over to try and keep it attached, but there's only one clip holding this in, and you know, if I can make it work, I'll make it work, but you know, I don't know if I'm going to be able to keep this on there, but we'll find out. But I wanted to show that because this is not something that I did. This is just how it is as I've got it. So I'll see what I can do to make this work here. Oh, and as I go to bend this backwards to hook it up, it's actually ripped right there, and it's ripped down here. So this whole thing needs to be just replaced. And the flyback appears to be original. It hasn't been replaced in the past. So I don't know if this is just somebody trying to stick screwdrivers under it and ripped it with their screwdriver. I mean, I think that's what's happened here. Someone's tried to discharge this monitor, this tube, or this chassis, even though it doesn't require discharging, it auto discharges. But someone's been sticking these tools underneath this cap, and they cut the cup and they broke the tab, and just, yeah, this is mishandling by somebody. But regardless, I'm gonna probably have to just replace this. But for now, let's just get it installed, and I'll replace it later on down the road. I want to see if this actually has collapsed or not. So stand by one moment. Okay, so we're all hooked up, and despite the issue with the anode cup, I was able to get it to be secure pretty much. So it'll be okay, good enough just for some quick testing. I got everything hooked up, ready to go. Anode neck, yoke, ground, power, and remote. I don't have video hooked up because we're not interested in video. We just want to see if it's collapsed or not. We don't need the video for that. And I also have B+ hooked up here, ready to go as well. You can put the positive right there on that side of L100 that feeds the B+ to the rest of the chassis. And the ground I just have hooked up right there to one of the bolts for the frame. So we should be able to have it adjustable to 117. And get my screwdriver here just in case we do need to adjust it. And yeah, we're secure on there. So let's fire it up and see what it does here. 1, 2, 3. Okay, comes on. And what do we get? Okay, we need to adjust our screen voltage here. Let's turn up our screen pot. And it's got the glue on it. Let's try our brightness and contrast here. Brightness all the way up, contrast all the way up. I get nothing. Well, maybe we can give it a video signal. Let's just, I gotta unplug this from my test monitor here. There we go. I didn't think we'd need video, but apparently we do, because I can't turn the screen pot because it has the factory glue on it. So let's just plug in a video signal here. And what do we get? Yep, collapse. Okay, verified. So we'll turn it off and set that back out of the way. Okay, problem verified. Let's take it back off the tube and see what we can find here. Actually, I realized I just forgot to test the B+. I mentioned it, hooked it up, forgot to test it. So let's turn this back on. Okay. Back on, and we are at 117.3. So my hypothesis of the pot being adjusted improperly is incorrect. I'm just used to it being a little bit more turned towards the filter cap than that, but 117.4 is good. So okay, not B+ is fine. And yeah, so let's see what we can figure out on this issue. All right, so back on the bench here, let's go over some stuff. One of the easiest things to check before you dive into a chassis issue is your remote board and your harness and your solder joints on the header pins for the ribbon cable, because if you have a broken vertical size pot, in this case it's a height, it says height. If your vertical size pot is broken or your vertical position pot is broken, you'll have collapse like that. So one of the first things you want to do is verify you don't have a broken pot. Now these type of pots are almost impervious to breaking and damage, but we can go ahead and remove the board from the holder here and just inspect our solder joints and things like that. Now this worked before. When they turned it on, it worked and slowly collapsed and never came back. So I don't think it's a problem with the pot, but you don't want to overlook the easy things first. So looking at our vertical size pot, it seems okay. It's not loose. And vertical position, kind of the same thing. They're right on top of each other. And yeah, visually they look okay. We can go ahead and use the meter here and make sure they read what they're supposed to. All right, so our vertical size pot, or in this case it's marked as height, should be 200K. Yeah, 200K. So if we go all the way down with it and we test this way, we get 168K. Yeah, it's not quite 200, but yeah, if we go the other way, it should of course be somewhat close to 0. Yeah, 1.3. So that pot's good. Now, vertical position, this again should be 0. Yeah, 1.3 all the way. Other way should be about 2K. And we get, do I have to go this way? 1.7. Not all pots are created equal when it comes to how you read them. Yeah, there we go. So 1.7 and all the way the other way, 1.8K. So yeah, this one reads differently than this one. Maybe, I don't know, let's go all the way that way. Let's try reading it the same way. 1.6 and yeah, so you read those differently. So anyway, all right, yeah, those pots are fine. Now we can check to make sure the ribbon cable has good continuity. So if we, for those traces there, this one comes down and goes through off to here, it looks like. We can just check the ribbon cable for continuity across all the pins. So if we go like this, okay, so it's not a pot and it's not a ribbon cable issue. So let's put this back together and set it aside. Ah, dang it. Okay, and it's not going to be caused by a neck board issue, so we can disconnect that and lift this little, I don't know what you want to call it, lid. Lift the lid, take that out. Take the G2 wire off, and we can discard our neck board for now. Okay, well, so let's check some of the easy stuff first. Is R303, should be about 1.2 ohms if memory serves. Now R303, so here's the chain of events here. R303 It comes, the voltage comes out, the 26 volt DC reference for vertical deflection comes out of the flyback, and it goes through R303, and it goes through D302, and it goes across this yellow wire up over here to this circuit. It runs through a couple of resistors over here, then it goes through D603, and it goes straight through into the vertical IC. So we want to start by checking R303 and verify that it is about 1.2 ohms. Oop. Sorry about that. Okay, hit the camera on my way down from the zoom in, or zoom out in this case. All right, so R303, 2.6 is kind of high, but that's not going to cause complete collapse like that. Okay, now we're reading properly, 1.8. Okay, and D302 should be, 0.5 voltage drop. And 0.45, that's good. Does it read both ways? It shouldn't read both ways. If I recall, it shouldn't read both ways, but it's going out of the range. It's probably okay. I'm not going to worry about that for now. It's not shorted, is all I'm worried about. It's not cracked in half, so it's not open, and it's not shorted. So I'm not going to worry about that too much right now. All right, so those are okay. It comes up here and goes through, let's see, it runs over here across R402. And R402 is 4.7 ohms, that's normal. And then it goes across here and goes through Q801. Q801 is going to be measured from the back side here, and we'll go back to diode mode. And I think it's base emitter to collector should be 0.5 voltage drop. Actually 0.7 and, okay, well, I'm not sure how to read this. There's 0.6 and 0.6. Okay, so your positive goes in the middle, and negative to each outer leg is 0.6 and 0.6. So that Q801 is okay. Then it comes out of Q801 and goes up through a couple of other resistors. And then it goes through off to test point TP205, goes through a jumper W111, and then it goes through this resistor here. And 212 I'm pretty sure is okay. $800 ohms. Okay, so let's check D603. D603 is this guy that resides right in here, and it should read the proper way, and it should not read the opposite way. If it reads the opposite way, then we've got a problem with the IC. So if we check D603, that's a good reading, 0.5 voltage drop. And we do not want a reading in the opposite direction. Okay, so nope, something's wrong there. So D603 should be open in this regard. So there's something wrong with the vertical IC. There should only be one pin that reads to ground. I believe that's pin 5. Pin 1 is, I believe it's over on this side. No, pin 1 is this pin on this side, reading from the bottom. And I believe pin 5 should be the only one to ground. So if we go to ground here, only one pin should read to ground. There's pin 1, 2, 3, 4, 5. Okay, so 5 is a dead short to ground, and pin 6 is a short to ground. So we've got a shorted vertical IC. You should only have one pin that reads to ground, and I believe it's pin 5. We have two pins that are dead short to ground. Pin 5 is a 0.5 and pin 6 is 0.5. So we've got a dead short to ground on a pin that shouldn't be grounded. So we need to remove the vertical IC and find out if there's something on the board that's shorted. Because if that pad reads to ground still, that shouldn't be, with the IC removed, then we've got something on the board that's shorted. And the IC should be okay. But if we don't, then the IC is the problem. So let's fire up the desoldering station here, because I don't use that often enough, and we'll use it this time. But we have a pin to ground that shouldn't be. Now, the easiest way to determine that is to measure D603. This thing's loud until it warms up. So like I showed you, D603 should only read the correct way your 0.5 voltage drop. If you flip the leads and you get a reading the opposite way, your IC is shorted to ground. And here is an actual perfect example of that situation. So if we flip this back over, and they said what, C601 was broken? Which one is C601? Let's look for that in the meantime. I thought it was a Mylar cap somewhere, but C601, yeah, there's C602. Okay, 601 was this guy. Right there, the Mylar cap right there. So it appears to be intact, and yeah, it was replaced. So all right, well, the problem with this is we have a shorted vertical IC. Now whether the IC is shorted itself or it's a pad problem, I don't know, but let's I got a few more degrees here to go, and we'll show you. I finally got around to unclogging and fixing this darn desoldering gun, because every time I use it, when I use it in a downward, I have to use it and then immediately turn it up and go like this. I have to use it and then turn it up and go like this, because otherwise this freaking thing clogs up on me. It's such a nightmare. The last time it clogged up, I just put it away and said, I'm not using that piece of junk again, but I got ahead and went ahead and unclogged it. But all right, so here, let's zoom in a bit more here. Oh, too far. I asked too much of it. Okay. Okay, now, before we put this thing away, we have to use the cleaner thing here and go like this. And it's it's freaking clogged already again. This should go all the way in there, and that little gap right there, it's not going in all the way. So I'll show you here. If I open this up, take this out, and you know, I can't use this without it clogging. See that? Look at that. See, this is what happens every time I use this, the stupid thing clogs up every time. It's just it's almost not worth even using it. See, now it goes all the way in there. See? So I mean, it's just I'm sure I can hear you guys screaming right now that oh, you need to get a Hacko or Hacko. Nope. The exact same thing happened. I bought a Hacko, spent $300 and some odd for a Hacko, however you want to say it, and the exact same thing happened the first time I used it, and I was never able to actually get it unclogged. So I can't find a decent desoldering gun that doesn't clog up on me with every use. I mean, you saw how I barely even used it to get that chip out, and it clogged up on me already. So it's just a nightmare. Okay, back to working, but next time I use it, it's just... All right, I'm gonna turn it back off now. Clean up all this mess that it pooped out on me. Anyway, but I'm not bitter about it. So, let's see if we're all clean on these here, and it looks like... Do we have free play on these? Where is my... Okay, that one's free, 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 free. All right, so that should come right out. So let's grab our little screwdriver here and you rascal, get out of there. There we go. IC is out. Now let's test it and see if it's shorted or not. But only one pin should read the ground, and I believe it's 5. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it's 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the IC is not shorted. Something on the chassis. That's interesting. So we'll leave this in continuity mode, and if we go to pin 1, which is, again, this one over here, we go 1, 2, actually we go to ground here, sorry. 1, 2, 3, 4, 5. Oh, well now wait a minute. 5 is our ground. This is a counterfeit. I think this is a counterfeit IC. Because if you notice here, the ground on the chassis is pin 5. 1, 2, 3, 4, 5. But if we go to the IC, so this is installed in this direction in the chassis. So if we measure it this way, and we go 1, 2, 3, 4, 5, 6. We've got a counterfeit IC on our hands here, boys and girls. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. That wasn't on ground. We'll do that again. For dramatic effect, we'll go 1, 2, 3, 4, 5. One, 2, 3, 4, 5, 6. So we have the ground in the wrong spot. This is a counterfeit IC. And to illustrate this, I have 3 of them, 3 brand new ones right here. So let's grab a good one. And if we do a contrast and compare here, I don't want to make a liar out of myself, but we'll start with the counterfeit one again. And we'll go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So, counterfeit IC. If we look at the part numbers, yep, it says TDA 1771. I don't know if you can read it, but TDA 1771 and TDA 1771. There you go, and 1771. So we have a counterfeit IC on our hands, ladies and gents. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So, counterfeit IC, get out of here. Now if we put the real one back in, I'm going to have to find out from the owner of this where they got that IC, because it's not the right one. Well, it's got the right stamp on it, but it is not. It's not a real IC. That's what happens. Based off my experience, the counterfeit ICs have the ground on the wrong pin, and they just relabel it for some reason. I don't know what it is. The person that does that kind of thing sitting there in their mom's basement going, "We got him, we got him." I mean, is that what they're doing when they bake these fake chips? That just always goes through my head. What are they? They make these fake chips like, oh, we got that guy's $6. All right, off to McDonald's. I don't get it. I just don't get it. All right, that is secure. Let's solder this in place and then we'll test it here. All right, that pad got a little lifted, but it's still good. All right, turn my fan on here. All right. So let's make sure we didn't short any of these together. Nope. 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 Test our leads. Yep. All right. So here's the ultimate test. I'm on ground. And we'll go 1, 2, 3, 4, 5. Oh, I'm not on ground. There we go. Okay. 1, 2, 3, 4, 5, 6. Nope. 7, 8, 9, 10. So we had a counterfeit IC installed. I think that was the cause of our problem. So now we're all soldered back in. We're hooked up with the screw. Everything should be good. Let's put this back together and try it, because I have a feeling that we had the counterfeit IC. Now, what caused the original collapse where it turned on and worked and then slowly collapsed and then permanent collapse? I think that might have just been a simple bad capacitor. And they did the cap kit and it fixed it. Or no, that's not right, because the chain of events here, sorry, let's look at the chain of events. Powered up 5 minutes later, collapsed. Did a full cap kit and vertical IC, still collapsed. Okay, so they did the cap kit, which probably would have fixed the problem, but they changed the IC with a counterfeit one, and that's what stuck it. So the original problem was probably caused by bad caps. And then I don't know why they changed the vertical IC. Maybe there is a step in there that is missing, but based off what the information that I have is that it looks like they did the cap kit, which would have probably fixed the issue, which explains why if you turn it on and it works and slowly comes down to collapse, that's a capacitor going bad. So I think the cap kit would have fixed the problem, but if they changed the vertical IC just to change it, they put a fake one in, and that was the cause of this entire problem from that point on. So before I lose my little tweezers cap, I'm going to put that back on because I have a tendency to lose those. All right, so neck board, we got ribbon cable hooked up, G2 connection, focus wire, all right. We'll hook up our remote board, and they reflowed those, that's good. All right, so let's do one more thing before we try this. When I have bad flybacks or flybacks go bad, I save the anode caps for an occasion just like this, because I've got one right here. What we can do is I need to actually take this apart and remove the cup. Well, that fell off. That fell off for me. Easy enough. And then we can transplant this over to this one. So let's see if we can make that happen here. Oh, that one's missing the cap already. That makes it easier. I don't want to rip my finger open here, but okay, there's that. Let's desolder this off of here. If I'm able to. Bend it open. So bend me open, but beware. There's things inside without a care. All right, in the garbage this one goes, in the garbage this goes. And now let's see if we can desolder this. This one's wrapped around here, so it may prove a little bit more tricky. Well, maybe not. All right, gonna throw this away. Now we need to get this wire up through here first. I've made that mistake before. You figure me out, you wear a mask, all counterfeit. You figure me out, you wear a mask. There's a deep cut for you. Figure me out, you wear a mask, all counterfeit. You figure me out, you wear a mask. Come on, you stupid thing. I should have lubed this up first. That's what she said. I'm going to use, actually I have some channel locks here. It's a rather blunt way to do this, but I just happen to have some big channel locks here. We're going to grab this and just pull it through here. Oh, come on, you rat bastard. Just need enough that I can grip onto. There we go. Thank you, channel locks, for doing your job. All right. So, if I recall correctly, this needs to be something like this. And we need to bend this over to it. Actually, I think it's this way. I think it's that way. There we go. And then we'll bend that over to it, and we'll simply burn the crap out of our fingers trying to hold on to it. There we go. That'll work, boys. Let that cool down for a momento. Then we can slide this back up over this. Actually, I need to turn this around, I think, the other way. And voila! Fixed. Now we have a new cap that's not all cut up, and we got leads that can go in, and good. All right, so now with that complete here, did I lose my, nope, here it is. I'm gonna lose it at some point. It's guaranteed. Figure me out, you wear a mask, all counterfeit. I need to make a thumbnail here, hang on. So, I don't really do professional thumbnails. I'm not a master YouTube content creator, so you'll have to forgive me here. Okay. So let's get this back on the tube now that it tests the way that it's supposed to and not shorted on 5 and 6. Actually, it wasn't shorted. The problem was that they had the ground pin on pin 6 instead of pin 5. Because it was a counterfeit vertical IC. And I'm assuming the owner of this changed this out when at the same time they did the cap kit as like a preventative measure, and they didn't need to because it was just bad caps. But regardless, let's see if our situation has improved. Let's get it on the tube and find out. All right, all hooked back up, ready to go. Let's see. We know our B plus is good, so we shouldn't have to adjust that if it does work. Contrast and brightness I still had all the way up, so let's turn it down a bit. And I popped the glue off the screen pot for the flatback so we can adjust that as need be, just to see if we can get it looking good. So, all right, fingers crossed. It was just that counterfeit vertical IC. Let's find out. 1, 2, 3. Okay. Ta-da! All right, let's go to vertical hold here. Bada bing! Woohoo! Brightness. Contrast. Oh, that's height. Sorry. Contrast is the opposite side. Yeah, not bad. Not bad. Well, there you go. I'm not going to bother with colors or screen size position, even though I did a little bit of adjustment there because it's not staying on this tube. And you might see some weirdness going on here. That's my chat. That's the PCB doing that, not the monitor. All right, so let's see if we can just make some quick adjustments here. Let's do contrast down, brightness down, screen pot up. We're not going to get raster lines here. We'll just go right about there till we can barely see it. We'll go right there. Now let's do contrast, brightness until the background is just black right there. A little bit more contrast. There we go. Okay. Yeah, disregard all that. We're way too green. Colors are wrong, but like I say, I'm not going to adjust those because it needs to be adjusted for the tube that's going on. But just to rule out, just to show you that it's actually not the chassis that's doing this, let's hook up. Maybe not, because I lost my sync connector here. And what happened to it? Ah, here it is. Okay. Well, let's turn this back off. And my MK board here doesn't like to play nice with some chassis. It syncs on some and doesn't sync on others and has that tearing and everything. So I use it for testing. That's why it's used for testing, because I can't reliably, or can't rely on it when it comes to using it in a machine. So, all right. So now let's turn on our TPG, test that. And it's a bit higher driven for the video signal, so yeah, there you go. Each position. There we go. Let's make sure our width is okay. Yep, width works fine. Vertical position down a bit and height a bit. And there you go. So it works fine. So thanks for watching. Hope you learned something. That darn counterfeit chip, it gets you every time. I appreciate it. Like, share, and subscribe, and we'll see you next time.